This is Algebra Lesson 2-1, Solving One-Step Equations. These are the beginnings of solving equations, which will get into multiple step equations using parentheses and the distributive property and multiple steps and variables on both sides of the equation. You name it, we'll get into it this year in this chapter. But this is the start of how to solve equations. An equivalent equation is an equation that has the same solution. Two equations are equivalent as long as they have the same solution. The additive property of equality says that I add the same number to each side of an equation will produce an equivalent equation. So, for example, if I have x minus 3 equals 6, if I add 3 to both sides of that equation, sometimes you'll see it written horizontally like this, x minus 3 plus 3 equals 6 plus 3. Both of those are equivalent equations. I prefer vertically, like this first one here. Most math books show it horizontally so they can show you that you're adding it to both sides. I prefer vertically because when we get into more complicated equations, it's much easier to show your work vertically than it is horizontally. The subtraction property of equality is similar to the addition. It just says that if you can subtract the same number to each side of an equation, you will get an equivalent equation. So if I had x plus 3 equals 6, I could subtract 3 from both sides of the equation. So x plus 3 minus 3 is equal to 6 minus 3, because I did something to the same side. Think of it as being a teeter-totter, and to keep that teeter-totter balanced, you have to add the same amount of weight to both sides of that teeter-totter. To isolate means getting the variable with its coefficient of 1 alone on one side of the equation. So in the above equation, if I have x plus 3 equals 6, to get the variable all by itself, 3 was added to x. To isolate x, I have to get rid of whatever was done to x, so I would subtract 3, thus leaving me with x equals 3. X was isolated. Inverse operations are operations that undo each other, like turning on the lights undoes turning off the lights. Tying your shoe undoes untying your shoe. Things that undo each other. Addition undoes multiplication or subtraction, and multiplication undoes division. The multiplication property of equality says that if you multiply each side of an equation by the same non-zero number, you produce an equivalent equation. So if I have x plus, now let's not even do x plus, let's just say x equals. Let's say x equals 6 is the same thing as 2x equals 2 times 6. All we did was multiply both sides of the equation by 2. The division property of equality says that if I divide both sides of an equation by the same non-zero number, I will produce an equivalent expression. So if I said 3x equals 12, if I divide both sides by 3, I will have the same equivalent expression. 3x equals 12 is the same thing as 3x equals 12. 3x divided by 3 equals 12 divided by 3. They're equivalent expressions. Now, you can find the solution of a one-step equation using the properties of equality and inverse operations to write a simpler equivalent expression. For the additive property, if you add something to the same side, it doesn't change it. So an example, x minus 3 equals 2, x minus 3 plus 3 equals 2 plus 3. The same type of examples as I showed on the previous slide here. The subtraction property, same thing. The whole idea of this is you need to get the variable by itself. And in one-step equations, you're either going to add, subtract, multiply, or divide to get Mr. Variable all by its little lonesome. All right, solving one-step equations. All right, x minus 3 equals 7. To solve this equation, I need to get x all by itself. Think of the equal sign as a fence that divides the equation into two different sides, the left side and the right side. On the left side, we have x minus 3, and on the right side, we have 7. I need to get the x by itself. If x was subtracted, 3 was subtracted from x. So in order to get x by itself, I have to undo that subtraction. So the undoing of subtraction is addition. So I'm going to add 3 to both sides of the equation. Now I know most of you can probably do this in your head, but you need to show the steps anyway, because when the equations get much more complicated, you cannot solve them without showing the steps, and I'll never be able to figure out what you did if you get the answer wrong if I can't see your steps. Now we can see that negative 3 and positive 3 undo each other, so they cancel each other out, and I'm left with x on the left-hand side, and 7 plus 3 is 10. And of course, we should always check all of our equations to make sure that we are correct. To check them, we're just going to plug in a 10 every place we saw an x. So 10 minus 3 is supposed to equal 7. Well, 10 minus 3 is equal to 7, and 7 equals 7, so that definitely checks. Equation number 2, negative 3 minus q equals negative 5. Technically, this is a two-step equation, even though it really sort of is. Some people classify it as a one-step. I classify it as a two-step equation, because if you see it, you see that negative 3, and you're subtracting q from that. You need to get q all by itself, but you also need q to be positive. So the first thing I am going to do is I'm going to add q to both sides of my equation. Remember again that the fence between the two sides of the equation is at the equal sign. So I'm going to add q. Now, q and 5 have nothing to do with each other. 5 is a number and q is a variable, so I cannot combine them. They are not what we call like terms. The q's cancel over here, and I have negative 3 equals negative 5 plus q, a whole new equation. So now to get q all by its little lonesome, I'm going to add 5. If I add 5 to both sides of the equation, it undoes this negative 5 with this positive 5. Negative 3 plus 5 is 2, and 2 equals q. Now, some people would have looked at the same equation, negative 3 minus q equals negative 5, and they might have said, oh, I'm going to get rid of the negative 3 by adding 3 to both sides of the equation, which is perfectly fine. You're doing the additive property of equality. Negative 3 and positive 3 cancels out, leaves me with negative q. Just don't lose that negative sign that comes in front of the q. Signs go with the number that they are in front of, or the variable that they're in front of, not behind. So this negative sign right here that I just circled in yellow goes with the q, not with the 3. So I still have my negative q, and negative 5 plus 3 is negative 2. Well, I don't want to solve for negative q, I want to solve for positive q. So to get rid of that negative, I either need to multiply by a negative number or divide by a negative number. That's not going to change the value of q other than its positiveness or negativeness, and that number is 1. So if I divide by negative 1, I will have negative q divided by negative 1, which is going to be positive q, and negative 2 divided by negative 1, which is positive 2. Of course, I should check these. So negative 3 minus 2 is supposed to equal negative 5. The only reason I put that in parentheses is to show you that the minus sign is still there. So negative 3 minus 2, remember from last chapter, keep, change, change. So we have negative 5 equals negative 5, and it definitely checks. Okay, the multiplication and division properties of equality. Multiplication property just says that if I multiply each side of an equation by a same non-zero number, I produce an equivalent expression. For example, if I have x divided by 3 equals 2, x divided by 3 times 3 is the same as 2 times 3. I multiplied both sides of the equation by 2, therefore I have an equivalent equation. The division property says dividing both sides of the equation by the same non-zero number produces an equivalent expression. For any number a, b, and c, where c cannot equal 0, you can't have c equaling 0 because if c is in the denominator, that means you're dividing by 0, and you cannot divide by 0. So 5x equals 20 is the same as saying 5x divided by 5 is equal to 20 divided by 5. So, solving one-step equations involving fractions. Now I have number 3 says 5/6 x equals negative 9. So x was multiplied by 5/6. To get x all by itself, I need to get rid of multiplying by 5/6. Now we don't write the division. We don't normally say, oh, we're going to divide by 5/6, because that's just not what we do in algebra. In algebra, dividing a number, if you remember from fractions from the last chapter, dividing is the same as multiplying by the reciprocal. So I'm going to multiply by my reciprocal here. So the reciprocal of 5/6 is 6/5. And if I do that to one side of the equation, I absolutely positively must do it to the other side of the equation. Whatever you do to one side of the equation, you must do to the other side of the equation to keep the equations equivalent. Now, as you notice, 6/5 times 5/6, if we do cross cancellation, 6 cancels with 6, 5 cancels with 5. I'm left with happy little x here who likes to be all by himself. And down on the right-hand side here, all I'm going to do is multiply straight across the top, straight across the bottom, and reduce if possible. Negative 9 times 6 is negative 54. 5 times 1 is 5. Now I could very easily leave my answer as negative 54/5, or if you so desire, you can look at that and say, oh, that's going to be equal to negative 10 and 4/5. That is fine too. Or you could leave it as the decimal, which would be negative 10.8. As long as it's a terminating decimal, a decimal that ends, you can leave it as decimal form. I actually prefer to leave it as an improper fraction because if I go to check it, I have to have the improper fraction form to check it in the first place. So my original equation said 5/6 times x, which is negative 54/5, is supposed to be equal to negative 9. Well, let's see here. 5 divides into 5 once. 6 divides into negative 54 negative 9 times, so I have negative 9 equals negative 9, and that checks. So my answer here would be negative 54/5, or negative 10 and 4/5. You probably should box or circle your final answers so that we can definitely tell you are finished with the problem. Let's look at number 4 here. 3x over 2. The 3x over 2 is the same thing as saying 3/2 x. So if I have something that looks like this, 3x over 2, that's the same thing as saying 3/2 x. Now if I have 5/9 x, that's the same thing as saying 5x over 9. They're just written slightly differently, but they mean exactly the same thing. So here, if I want to get rid of the 3/2, basically, because I have x is multiplied by 3 and divided by 2, so I need to do the opposite of that. The opposite of dividing by 2 is multiplying by 2. The opposite of multiplying by 3 is dividing by 3, so we're going to multiply both sides by 2/3. Multiply the left side by 2/3, multiply the right side by 2/3. This 3 cancels with this 3, this 2 cancels with this 2. I'm left with a happy little x on the left-hand side. 3 goes into itself once, it goes into 12 4 times, and 4 times 2 is 8. If you can learn to cross-cancel, you'll be much happier because it will simplify your multiplication and speed up the process. Of course, we should check it. Always check your answers. So I have 3 times 8 divided by 2 is supposed to equal 12. Well, 8 times 3 is 24. 24 divided by 2 is equal to 12. So 12 equals 12, and it checks. Number 5 here. Number 5, negative 96 equals 4c. To get c by itself, you'll notice they multiplied c by 4. The inverse operation of multiplying by 4 is dividing by 4. And again, we don't show division with the symbol like this. We show division with the fraction bar in algebra because it's neater, less likely to make a mistake or think it's a subtraction sign or an addition sign or something else like that. So if we divide the right-hand side by 4, we need to divide the left-hand side by 4. These two 4's cancel out, leaving me with a happy little c there. And negative 96 divided by negative 4 is going to be negative 24. Okay, and we should check it. So negative 96 is supposed to be equal to 4 times negative 24. Let's see, 4 times 4 is 16, carry my 1. Yep, negative 96 does indeed equal negative 96, so that checks. Problem number 6 here. X divided by 4 equals negative 8. So since the only thing they did to x here is they divided it by 4, I'm going to do the inverse operation, so I'm going to multiply it by 4. I multiply the left side by 4, I multiply the right side by 4. And it doesn't matter what symbol you use for multiplication, whichever one that you find easier for you to use. You can use the dot, you can use the parentheses, you can put the 4 over 1, you can leave the 4 as a whole number, it really doesn't matter. However you feel that you show, just so you can show what you're doing and you understand what you're doing. This 4 cancels with this 4, leaving me with x. Negative 8 times 4 is negative 32. So to check this guy, negative 32 divided by 4 is supposed to equal negative 8. Well, I happen to know that negative 8 does indeed equal negative 8, so this checks. Now, as well as regular problems, we also have to deal with what we call real-world problems, basically word problems. Because when you get into the working world, which is what I like to call it, rather than the real world, because you do live in the real world, you just have, your real world happens to be school. Eventually, your real world will be the working environment, whether you work as a stay-at-home parent or whether you work in the workforce someplace else, you're still going to be dealing with things in which they're not going to give you the problems written out. You're going to have to problem solve, which is basically what word problems do. So Rob is driving at 40 miles per hour. Stacy is driving 3/2 times as fast. How fast is Stacy driving? Well, if you're going to solve an equation here, you're going to write and solve an equation. The first thing you have to do is define a variable. 99.9% of the time, your variable is defined by what the question is asking. And here they're asking for how fast is Stacy driving. So we need Stacy's speed. Okay, so I'm going to let x equal Stacy's speed. Because I don't want to use an S because S can look a lot like a 5. So I'm going to use an X because it just makes it nice. Okay, so Stacy is driving 3/2 times as fast as Rob is. So we know that 3/2 Rob's rate equals Stacy's rate. I know Rob is driving at 40 miles per hour because it tells me that. So I know that 3/2 times 40 is going to equal x. Now this is one type of equation where you don't even actually have to add something to both sides, subtract something from both sides, multiply by something from both sides. You just have to work the equation out. So I'm just going to work it out. 3/2 times 40, 2 goes into 40 20 times. 20 times 3 is 60, so 60 equals x. So Rob is driving, or excuse me, Stacy is driving at 60 miles per hour, which seems like a reasonable answer. Because if I look at this, Rob is driving 40, Stacy is driving 3/2, which is 1.5 times faster. So if she was driving the same speed, she would be driving 40. Half of 40 is 20. Add that 20 to 40 and you're going to get 60. So this is a very reasonable answer. That's the last thing you should do when you look at a word problem. Check to make sure it is reasonable and you've answered the question they've asked. Once you've done that, you should write your answer in a complete sentence. Always write word problem answers in a complete sentence. So my answer here would be Stacy is driving at 60 miles per hour. And you can abbreviate the miles per hour if you would like. But always answer your word problems in a complete sentence so that any normal person could read it and go, oh, that's the solution to the problem. All right. Last thing, our question for today that I'd like you to answer in your notes, our closer question is, when solving a one-step equation, how do you know which operation to use in order to isolate the variable? So think about that, answer that question in your notes, please. And that ends this lesson.